Thank you very much. Actually, it's been a very steep learning curve sitting in the audience for the last day and a half, so I've been able to contextualize my presentation a little better being towards the end, so I'll steal a few seconds from my spiel here to say this is an example of a kind of MacGyver school of geodesign. So you can kind of, for those of you who catch the TV reference, it's improvisational, shall we say. So my research group is, we are 3 faculty members in architecture, landscape architecture, and community planning. And what we do is develop methods of what we call measured visualization for public engagement. And you can see at the bottom that that has a lot of scope to it. We do everything from design tools to case studies to indicators and metrics. But the agenda through all of this is actually very straightforward, and it's the same thing I've been doing since I graduated from graduate school, and you can imagine that that was a while ago. Our agenda is to elevate understanding of sustainability, and specifically the metrics of sustainability, how do you know when you have it, within these public engagement processes as a matter of course. We have always had the opportunity of projects that do it as a matter of special occasion, but we've been trying to figure out how to push that down into those everyday practices of community planning. So there's many challenges here, but one of them is this one. And that is that if you kind of plot the design process across the horizontal axis of this graph, as a project moves through these phases, it turns out you have to make the most influential decisions about what goes where and how much of it at the very beginning. So here you have a place where there's a lack of information, a lack of time, and a lack of resources, because that information line roughly parallels the fee structure of most projects. So where the resources are does not line up where the opportunity to influence is. And we're interested in that little red spot down in the bottom left corner. So this is our research lab. We've spent a long time working at all these different phases of many different projects. We don't often follow one from beginning to end, but they take about 16 months, and if you kind of follow what happens to a community planning project as it moves through all these phases, and what happens to the transformation of information and the ability to measure sustainability as it moves from one step to the other, you kind of get a sense of, we're trying to figure out how to do that better. So among the things that got our attention first was that when we looked for tools to help us, there was big gaps in the set, and they were especially here at this kind of transition between scoping, exploring, and testing. And the reason that's so important is because that's kind of the interface where all the words and numbers of policy end up being translated into something physical and spatial. And so having good ways to kind of see how the things you care about and can measure kind of find their way into something geospatial, or in the case of or architectural. So I'm going to talk about just a little tiny subset of the work we've done, and it's 3 tools that we've linked together. One of them is our tool that we developed actually as a teaching tool way back in the 90s. The middle one is an application of that to a design touchtable environment, and the last one is a kind of a transition to CityEngine. So just to kind of map this, at the root of this discussion is this capability of this database that we've been building for years, and then we port information from it to this design touchtable, and that's a tool for early stage consultation. And then we port the same information in a different form to a CityEngine application for a later state of refinement. And I'll explain more about how that works. So let's start with the web application. This is something that, for those of you who've been in the field a long time, might appreciate this. This used to be a FileMaker Pro database on my desk in my faculty office back in University of Oregon way back in the day. And so the idea here is that this is a web application of familiar, instructive, replicable examples of urban form and land use. And what we've done here is we've gone out and kind of captured benchmark or illustrative projects in all these land use categories. And we've kind of captured them so that people who want to know about these can kind of link the words to the pictures to the numbers. And so depending on what your interests are or your particular lens is, you can search by words, or you can search by pictures, or if that pink building on the corner, or you can search by what is a mid-rise mixed-use building. You can kind of get the picture. So these are all real places, and they're all measured and illustrated to exactly the same protocols, mostly by students. But when we got more successful at it, we also had research assistants. So here's a kind of a snapshot of a collapsed page. So you get a combination of quantitative data about planning things, site design things, building things, environment and energy attributes. And on the right-hand side, you get visual, spatial things. There's a 3D model, there's a site plan, there's a bunch of walk-by images, and more recently we added Google Map links so you could go visit where we got the case from. So the way this was designed was that we always thought that you learn more about how cities are made by kind of putting familiar pieces together. So you could go, look at a 2.5 FAR building and put it next to a 1 FAR building and actually experience what happens if you aggregate that. So we designed this to be able to take particle scale cases and move them into different kinds of compositions. And so you could look at this sort of neighborhood scale one. These are all cases from different places brought together into that illustration in the middle. And then you can drop them into real neighborhoods and sort of show what might happen if you populated a corridor plan with a certain building type. So because there's quantitative data associated with these, it also allows you to kind of interrogate the picture with a kind of understanding of things that might help you measure things, whether it's land use or cover or floor area or envelope and aperture, to kind of create the beginning of the evidence of the sustainability potential. Now, just a small point, you also can toggle the models in ways that you can emphasize what's measured in that version. So the land use one is different from the aperture one, is different from that. So the first application here is the design touch table. And this sits right at the front end of this little red line. And it's a place where we want people to be able to generate alternatives, see them, and measure them ever so slightly. And the idea here was that this need not be a professionally driven one. We wanted it to be able to be used by people who had never done this before. So a lot of the design of the touch table is cobbled together, and this is where the MacGyver comment comes from, in ways that makes it kind of accessible to many people. So it's a very interesting collaboration. I've been working on this for a couple of years. In addition to my lab partners, we have collaborators in geography, computer science, both on the database management side and on the human-computer interaction side, and planning, et cetera. So I'll just tell you a little bit more about this. So the pieces of this is in a way patched together existing applications. We use Google Maps for the map. We use Google Earth for the 3D visualization. We wrote the Flash programs for the metrics. The case palette is linked elements DB. Really what we did is write software that lets these things talk to one another in some ways. So we've used this in a variety of ways. We've used them in public workshops. I spent 2 days in a shopping mall with it, which I'd like back someday in my life, but we've used it in community centers and a high school, et cetera. And usually when we do that in a group, the table, which we actually made with a TV from Best Buy, and then we made the table in the CNC machine at the architecture school's shop. And then we project the Google Earth representation on the back, and then the numbers you see are the little flash widgets that we built into it. So I'm just going to show you the video of one example. So this is one that we weren't doing in public, but rather with a group of senior planning staff members from the city of Vancouver, and you can see what disciplines they represent, and they're all clustered around the table, and we're using, in this case, a TV monitor, because it's not great to step back every 5 minutes and look at what you made on the wall. So there's the elements DB cases that are linked to the table. There's 4 palettes so that people can have access to the same information. And then I think, coming up very soon, that you'll see how the palette works. You drag it with your finger into the play space there, or the workspace, and then you can move it around, get it in the right place, and then it shows up on the 3D visualization, and the little dashboard dials about how many people or estimates of mode split and other things are constantly being refreshed. And then because people never were in the right place, we had to figure out how to help them move around. So if you push your finger on the map, it'll turn the camera around and you can see it from that direction. So the next tool is on the other side of that, which is to kind of use CityEngine to do later stage refinement, because once you have these coarser models, you need to be able to add greater detail and specificity to them. So this one, we went back to the same idea, is that the database really provides all these examples, except in this case, rather than making 3D models of them, we made parameters for them. So we kind of decoded every one of the cases in our database and turned them into rules. So here's an example. There's the real building on the left and the digital model we made for Elements DB, and then there's our deconstruction of what you see into parametric-based rules. And then we drop these into bigger models, which are always hybrids because the areas that we have GIS data from are different than the ones we have CAD data and different from the ones we want to be able to model. So you can kind of see how we make patches of things to kind of focus the task. So this particular one is going to be an example of working with an urban designer and a land use planner from the city of Vancouver. And what they've done is they've taken table models of those patches that you see in yellow. And what we're doing now is we're using the sliders of CityEngine to kind of manipulate the regulatory levers that they have, parcel size, setbacks. You know, in Vancouver, it's very common to do the top 2 floors step back so you can kind of shape the massing in ways. So this is all happening. I mean, I've sped this up to show you what the effect was, but they're telling us what to do. Let's take those 3 blocks and let's change the setback, or let's keep the FAR constant and change the parcel size. So quick transect through how we put them together, and we've done this in small cities for climate change planning and big cities for transit planning. But this example is from a community plan for the city of Vancouver, which we finished about 1.5 years ago. So when we came into this, there was this draft policy plan, which really just shows you what land uses and what densities go where. So what we did first with the planners is identify what we called urban form samples, because it's very difficult to do this quickly with the table. So we just grabbed 3 kind of representative pieces, and then we did multiple iterations of those on the table. We slipped the policy underlay under the Google Earth map so that people could kind of see how that related to what they were doing. Then we take those same patches and we drop them into the CityEngine model, and the same numbers are there, 1, 2, and 3 of those little patches. And then, as you've already seen in the movie, we're working in a interactive way with the planners and the urban designers who are sketching things on the table and barking in the ear of my research assistant here, who's basically taking those sketches and manipulating what the possible variables would be. And then finally, in terms of reporting out, we link these back to the policy goals. So this is one sample of that same project where we took the exact phrases out of the policy document: housing diversity, access to transit, access to open space. And then we showed, using both the map and the infographics of quantity, how the proposed plan shifted the existing place from A to B, both spatially and in terms of performance. And that's me, and I'm done.
Great. Thank you, Ron. Yeah, great. Thanks, Ron.